Okay, next question was this one. Again, actually a really easy question here. And there was now, to be fair, I didn't say you couldn't use your calculator to do it. So some people did use their calculator, but this was the way that I was thinking you were going to be doing it. So when we have two logs and they don't have the same base, which, sorry, I'll rewrite that. It's a little bit blurry. So this is what the question was. So I have two logs here that do not have the same base. So you change it to the smaller base. So I'm going to leave him as he is. This one, I'm going to change it. I'm going to change the base. Now, what do I do? Remember, the big number goes there and the base, the old base, goes there. Now, what you'll notice is, again, turn this into a fraction if it's not already. They cancel, and I'm left with the log of 4 to the base 2 equals 2. That is the log of 2 squared equals 2. Remember, when you're doing logs, you can bring the power to the front. 2 log of 2 to the base 2. Any matching log and base is 1. So therefore 2 equals to 2. And that's all I was actually looking for. And that was worth 5 marks. For those people who did change it using the calculator into a decimal and you had enough decimal places in your decimal to get 2, then I gave you the marks. Some of you got a decimal, but you rounded it and it wasn't exactly 2. So I didn't give you full marks. And anyone who did it this way obviously got full marks. So anyway, for future reference, that's all I was looking for there. Change a base. Next one, so straight away I see that this is an indices equation. So we practice lots of these in class. So I break this down into 2 to the power of 2x and 2 to the power of 1. So that's how I begin. Then I say to myself, it's 2. Now you can break this down again if you want and put the 2 outside if you want to do that. Ultimately, it's one of those ones where we substitute. So we're going to let y equals to 2 to the power of x. So we end up with y squared times 2. So we'll just put the 2 to the front, minus 5 times y minus 12. So it just turns into your regular quadratic really at this stage. So we open up 2 brackets, 2y and y. The minus means the signs have to be different. So we're going to go with plus and minus, for example, and 4 and 3. Is that right? 4 and, oh no, sorry, it's not 4 and 3, it's 3 and 4. It's 3 and 4. So just switch them around. 3 and 4. 3 minus 8, yeah, so that works. So we have 2y plus 3 is equal to 0, and y minus 4 is equal to 0. So that's 2y is equal to minus 3, y is equal to minus 3 over 2, and y is 4. Now, are we going to accept both answers? Well, remember, ultimately, they're both going to be equal to 2 to the power of x. I know that that's never going to work because no matter what I raise to 2, so whether I raise it to 0 or minus 3, like if I raised it to minus 3, it would be 1 over 2 cubed. So it's 1/8. It's still not negative. So we have to get rid of the negative. That ain't going to work. This one, remember, we try and get the bases to match. And as soon as we have matching bases, we get to our answer, which is 2. And that was worth 10 marks. The next one, consider the graphs below and identify the nature of the mapping in each case. Not a function, 1-to-1, onto, 1-to-1, and onto. So you're basically being asked, are they functions or not? And if so, or if not, well, actually, if so, is it the 1-to-1, is it onto, or is it bijective, basically? Is it both? So looking at this first one, if I do my vertical line test, whether I do it there or over here, it's going to hit the graph just once. So this is a function. Okay. This one, put the vertical line test in, it is a function. So they're both functions. Now, when you're deciding between 1-to-1 and onto, this is when you do the horizontal line test. If I do my horizontal line test there, I can see that it meets the graph once, okay, in that position. Now, however, does the domain equal to the range? So we'll get to that in a second, but it does meet it once. So for that reason, it is 1-to-1. So we can call it a 1-to-1 function or injective. And why is that? It's because every input gives a different output. Now, what about the well, what about whether it's surjective or not? Is it onto or not? So I suppose it does touch the graph once, but we have to consider whether the range is equal to the codomain. So my question really is the range equals to the codomain? Now, the codomain are all the possible y values. Here, we haven't been given any restrictions. Sorry, that's actually very faint there. But it does say or for the range. So the range is every single thing along the y-axis, every number you can think of. Now, the problem here is we have an asymptote. So the asymptote, I'll do it in a different color. The asymptote is along here. Now, what that means is there is a value there so in other words, 0. When y is 0, that is not in the range. That's in the codomain. So 0 is part of the codomain, but 0 is not part of the range because it's an asymptote. In other words, the graph can't actually touch it. So because they're not equal, it is not surjective, or it's not on an onto function. And then if it's not surjective, well, then I also know that it's not bijective. Now, I didn't mind if you didn't give me all of that. What I was really, for 5 marks, I wanted you to say it was a function. And I wanted to say, if you had said it's a 1-to-1, then I accepted that. You didn't need to tell me about the others. Regarding the other side, this was also worth 5 marks. So if I do my horizontal line test on this one, anywhere, just horizontal line test, I notice that it meets the graph in 3 places. So it's not 1-to-1. To be 1-to-1, you can only meet the graph not at all or once. So in this particular case, it bypasses that. So it's not 1-to-1. Okay. In other words, there are double ups. Okay. So it's definitely not 1-to-1. So like 1, the number 1 gives us the same value as, for example, -3. No, maybe not -3 actually, but -2 gives us. Okay, and that's not okay. So it's not a 1-to-1. There's not just one x going to a y. Is it surjective? So in other words, the range is or. You can see it there, I think, just about. The range is or. So the codomain is or. Is the range also or? Absolutely. There's no restriction. So because the range equals the codomain, then for that reason, it is surjective, or you can call it an onto function. Now, because it's not both, it's not bijective. Now, again, I didn't need you to tell me everything. If you mentioned that it was a function and you mentioned it was surjective, I gave you the 5 marks. So that was that one. Okay.